Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the motion in a straight line, class 11 physics. Written here, I will discuss position and position vector, reference frame, displacement and distance travel, speed and velocity, instantaneous velocity and speed, instantaneous acceleration. This term I will discuss. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT exam and NEET confidently with a good rank. Now let's start about the class. What is position? Position means in a space, position is determined by a reference axis. In class 10, that is position of a particle is in a plane is measured by two distance, that is x and y by coordinate. This is x comma y, means that is distance from y axis is x and distance from x axis is y. So from by the two axes we fixed a position of a particle. So position of a particle is a scalar quantity, it has no direction. Now if we put the position vector, so position is scalar, but when we add the term vector, then this is position vector, so this is vector quantity. Now we know to describe a vector 2 points are required. Here this is 1 point, so position vector of this point, to define the position vector of this point we must consider other point is origin. So O to P, this is the position vector OP. Now position vector OP is if unit vector along x axis is I and j, OP equal to vector equal to actually xi plus yj. This is position vector. Position, so position is a scalar. Position means this point is fixed at that point, and when we add the vector, then this will be the vector. So the other point must be origin, O to P. This is the position vector. So position vector has a direction. If we take this point at, so it has a direction in this way, it has a direction in this way, in this way. Suppose if the point is here, the direction is along this direction, so it has a direction. That's why it is a vector. We know the position of a particle is determined by certain number of axes. So the reference frame is very important to describe the motion of a body. If a body is at rest, we generally say that the body is rest or motion, but motion and rest is completely relative. If a body is rest, then with respect to one reference frame, then it may be in motion. Suppose consider a body, consider a bus. In a bus, a man is present. This is a ground, bus, ground. Suppose this is a bus is moving with a velocity, and two men A and B is in the bus, and another person C is in the ground. Now consider the motion of B. If the person B, if we consider the motion of the person B, then the person B is at rest with respect to A. The person A, C, the man B is at rest because both are moving with same velocity, but person C, that man is moving with velocity u. So with respect to C, the man B is moving, that is in motion, and with respect to A, the man B is at rest. So this is completely motion and rest completely depends on the reference frame. Here with respect to the bus reference frame, the person B is at rest, but with respect to this reference frame ground, person B is moving with velocity u. So motion and rest are completely depend on the distance travel means total path covered. Total path covered. Suppose a body moves here, moves like this way. So total path covered, that is this, if we measure by s, take this total path length is distance covered, s, total path covered, and displacement equal to shortest distance between initial and final position. Shortest distance between initial and final position, that is this A to B. This is initial, this is final. So shortest distance, if we join this line, so this is the displacement. AB is displacement. AB is displacement. So displacement is a vector because it has a direction. We have to measure A to B, join. So this is the it has a direction. So displacement is a vector quantity. Vector, but distance is scalar. It has no direction. Distance travel is scalar. Now always displacement, magnitude of the displacement is always less than distance travel. That's displacement is less than distance travel. Displacement always less than distance travel. Moves in a circle. So what is the displacement? Suppose the radius is r. A body moves in a circle of radius r. So what is displacement in one revolution and distance travel? Displacement and distance travel, both. Distance travel. Displacement and distance travel in one revolution. What is the answer? One revolution. So revolution means that is particle moves after one revolution. So here initial and final point. Here initial and final point are same. So displacement is 0. Displacement equal to 0 and distance travel equal to 2 pi r. If a particle revolves a semicircular path, then A to B, here distance travel equal to pi r and displacement equal to AB, the shortest distance between A and B. This is the initial point, this is the final point. So what is the shortest distance? Shortest distance is this. So AB equal to displacement. AB, A to B, it has a direction. Displacement equal to AB. So that is 2r. Here we take the magnitude of the displacement vector. So this is 2r. Now what is speed and velocity? Equal to velocity equal to displacement by time, and average velocity equal to displacement by time. So this is called average velocity. Average velocity equal to displacement time, and speed equal to distance travel by time. Suppose a particle or body or person moves this direction 3 meter in 3 seconds and 4 meter in 2 seconds. Meter in 3 seconds and 4 meter in 2 seconds. So what is the speed? What is the speed and velocity? Average velocity. So speed equal to, we know, distance travel by time. Here distance travel is 3 plus 4 by time. Time is 3 second plus 2 second. So that is 7 by 5 meter per second. And average velocity equal to, we know, distance displacement by time. So displacement equal to, here suppose this is A, B, C, AC by time. AC equal to, by Pythagoras theorem, this. So this, here speed equal to this plus this, total path this plus this by time, and velocity equal to displacement by time. Now if a body moves in a circular path, suppose this is a circle of radius 1 meter in time, suppose 2 seconds. Now what is the velocity? Velocity equal to displacement by time. So displacement here AB by 2, AB equal to 2 by 2, that is 1 meter per second. This is the velocity, and speed will be path. Path means AB, A to B. Here path is ACB along the AB via C. So ACB by time taken is 2 seconds. ACB means pi r. Along straight line. Then we velocity, that is Vx and Vy. Only one component. Velocity has one component, Vx and Vy. But if motion in 2D, that is motion in plane, then particle has two component of velocity. That is, suppose particle moves in such a way, in this way. Here motion, this is motion in plane, motion in 2D, x and y both changes. Motion in 1D means only one coordinate changes, that is x changes. Here x changes, here only y changes. So this is motion in 1D. And if two coordinate x and y both changes, then it is motion in plane or motion in 2D, both changes. So suppose the particle is hit here. Now it has two velocities. Suppose the particle moves in this path, curve path. Now at point, instantaneous velocity is along the tangent at that point. Instantaneous velocity is this, and it has two component, Vx and Vy. So V equal to Vxi plus Vyj, and magnitude of velocity is this. Now the instantaneous velocity is a vector, and the direction is along the tangent at that point, and the magnitude of velocity vector is instantaneous speed. So velocity at any instant is called instantaneous velocity. Velocity at any moment or instant is called instantaneous velocity. Velocity at any moment or instant is called instantaneous velocity. And what is instantaneous speed? So instantaneous velocity is a vector. Instantaneous velocity is a vector, and the magnitude of the instantaneous velocity will be the instantaneous speed. Magnitude of V is instantaneous speed. Motion in 1D means only one coordinate changes. Vx means only x changes, y is constant. Vy means only y changes, x constant. So this is motion in 1D. And when coordinate of x and both changes, then we call that motion of the particle is motion in a 2D or motion in plane. Suppose the velocity of a particle changes. Velocity of the particle changes according to the time. Suppose this is t for time and v is velocity. Now for every moment velocity different. Suppose t equal to 1 second, velocity equal to 2, t equal to 1.01 second, velocity equal to 2 into 2.02 second, this t equal to 2 second, velocity equal to 4. That is, for every moment velocity will be different. So at a particular instant is called instantaneous velocity. At a particular instant, at a particular instant, velocity is called instantaneous velocity. Now, how to calculate the instantaneous velocity? How to calculate the instantaneous velocity? Velocity, suppose constant velocity v. If a body moves with a constant velocity for the distance x in time t, then we, that is velocity at every point is constant, then we can write distance equal to constant velocity into time. So that's, from this equation we get velocity equal to distance by time. But if the velocity changes for every moment, if velocity changes at every moment, then how can we calculate the velocity? Suppose the body moves in this direction, here time is t, and after t plus dt, suppose this time is t plus dt, this time is t plus dt, and for that time distance is dx. Suppose this distance is dx. Now at that time t, what is the velocity? So to calculate the velocity, we have to consider for this path velocity is constant. So velocity, suppose this point velocity equal to v, velocity v at time t, that is at instant t, velocity is v. Now instant means at that moment. So suppose later time, small time after t is t plus dt. So at that time the body moves some distance. Now this distance is dx. Now if the velocity, if you take that for this path velocity is constant, actually velocity changes, but if you consider that velocity at this path is constant, then that constant velocity into time taken dt equal to distance travel dx. So v into dt equal to dx, that is v equal to dx by dt. So here that's why we get instantaneous velocity equal to dx by dt. So velocity is instantaneous if dt is very small. So for time small we use dt. Actually velocity equal to del x by del t. For time interval del t, the distance travel is del x. Now we have to consider the time. This time is very small, then it will be the instantaneous. If the time gap is very small, then this is called instantaneous velocity. So now this we know by calculus, we know this is dx by dt. So always distance equal to velocity into time. For that distance, velocity suppose constant, it does not change. So that velocity into time taken, equal to distance. For that this. So for to consider it is at instantaneous, then time taken should be very small. So if the time taken is very small, then we can say that this velocity is at here, this velocity is at here. So this is the concept of instantaneous velocity. Now to calculate this, we have to know the formula of derivative which have been discussed in another video. Now instantaneous velocity is a vector quantity. Vector quantity and magnitude of instantaneous velocity equal to instantaneous speed. Same instantaneous acceleration equal to del v by del t, means in time interval del t, if the change of velocity del v, then if we take the time gap is very small, then it is called instantaneous velocity. So this if the time gap is very small, then it is called the instantaneous acceleration. So this is instantaneous acceleration. This is called instantaneous acceleration. Now a equal to dv by dt. So if we adjust this as dx, divide dx here and multiply here, then dx by dt is v. So acceleration, the another formula of acceleration equal to, another formula of acceleration a equal to v dv by dx. So these are the formula. Students, this is the end of the class. To get more such type of video, subscribe my channel. Okay, thank you.